Yeah. Three, two, one. We are live. Over to you, Vijay.
Good evening, everyone. I'm Vijay Subramanian. Welcome to the day two of the and webinar three of the Changemakers Summer Camp webinar series. During the first day of the webinar series, you got to learn about the key 21st century skills that we need to acquire in order to thrive in the new age. And you learned about the mega trends that is shaping our lives today. The trends keep changing and the world is changing every day. For being part of the change or to bringing that change starts from thinking creatively, then tinkering on these creative thoughts, and then comes the experimentation. So these skills, that is creative thinking, tinkering, and making, that is the experimentation and practical application, will help you to enhance your ability to thrive in the new age of smart technology and smart machines. Today's session will be conducted by Today's session will be conducted by Miss Kritika Ashok. She is the co-founder and director of R&D at GyanPro, a for-purpose, impact-first STEM organization which researches, promotes, and teaches conceptual learning of science. She enjoys the process of developing science activities to make the learning more fun for students and has performed 800 plus science shows across India and conducted 1,000 plus STEM workshops for students. Ms. Kritika is also a mentor of change associated with Atal Innovation Mission, Niti Aayog Government of India. In today's webinar, Ms. Kritika will show how science can be learned through a fun and exciting hands-on activities and experiments using simple materials that we use in our everyday life. I hope all of you have brought the suggested tinkering resource materials to this webinar and are ready to have fun playing with them. If you have any questions during the session, please type it in the Zoom chat window or YouTube chat window. We will take them at the end of the webinar. Before we start the session, I request all the participants to make their attendance in the Google form, whose link is being shared in the Zoom and YouTube chat window. This form link would be only open for the duration of the session. Those who attend this session and fill this attendance in Google form will receive a participation certificate at the end of the summer camp. So now let me invite Ms. Kritika to start the webinar.
Thank you so much, Vijay, for that introduction. So first of all, let me thank the core team of Changemaker Summer Camp for giving me this wonderful opportunity. And I'm really honored to be part of this program. So hi all. Yes, so I would really request all my little scientists here to kindly turn on your web camera so that I get to see you here, right? Otherwise, it looks like I'm talking to myself and doing experiments. It doesn't look good, right? Okay, so before we start, how do we communicate here? So if you agree to me or if you say, okay, then just give me a thumbs up. Can you all hear me? Yes, I want all of you to show thumbs up. Yay, yes. And in case if I'm not audible or you don't agree something, then you just show me a thumbs down so that I'll agree. I mean, I can get to know. All right. Are you all ready? Are you all excited about the program? Yes, then give me a thumbs up. Yay, very nice. So I'm sure that you're all ready with your materials. Is it so? Yeah? Yes. All right. So any idea what is that we are going to learn in today's session? Do you all like science? Yes? You can also type it in the chat. Or if you want to speak, you can just raise your hand and maybe we'll give chance to a couple of them to answer. All right. So why do you like science, children? What comes to your mind when you think about science? So you do not have to give me any book answer, book definition. Okay. Just think what comes to your mind. You just put it in the chat. Interesting. So now Nandi Shri has message, it is interesting. So science is interesting for her. Okay, how about others? What comes to your mind when you think about science? We can learn new things. Yes, of course. Good. Practicality. Very good, Satya. Yes. And then experiments. Exactly. When you think about science, you think A lot of experiments. Yes. Fun to learn. Yes. Fantastic. I've got quite a few good answers. We can do experiments. Yes, exactly. So virtual high five to all of you who have answered to this question. Very nice. Yes. Science is fun. Science is interesting, isn't it? So can you see science around you? Is there science around us? Yes. How do you say? Can you give me some example? Okay, it is creativity. All right. Where do we see science? Everything comes from nature. Exactly, nature, where we learn a lot about science in our day-to-day activities, in our kitchen. Wow. Light, nature, very good. Nice. Okay, so science is something real, isn't it? It is all around us, right from the breathing that we do. Yeah, inhale, exhale. From there to kitchen, cooking food, everything involves science, isn't it? Okay. Now, today's session, the topic is all about tinkering and making. Any idea about what is tinkering? Anybody would like to answer to this question? You can unmute yourself and talk to me.
Rudra Kashyap, please unmute yourself. Yeah, you can speak, Rudra Kashyap.
Okay. Good evening, all of you. My name is Rudra Kashyap. I am studying in 6I DPS Gaya. So tinkering is repairing old things.
Very nice, Rudra. Yes. So according to Rudra, tinkering is repairing old things. Any other answer? Lokakshi has raised your hand. Any other answer?
Yes, Lokakshi, you can unmute and speak.
Yeah, hi ma'am. This is actually from my mother's account, but my actual name is Harshika. I'm from DPS Bangalore South, 7th going to 8th. So basically, tinkering could be any way, like innovating or when you're experimenting with new things or bringing up new change among yourself. So it's basically innovating for me.
Exactly. Very good. A virtual high five to you as well. Yes. So tinkering is very simple, children. So see, science is not at all difficult. It is not at all complicated. It's just we make it complicated. Okay. So if you understand how it works, then it is very simple. So tinkering is nothing but, we'll make it very simple. Okay. It is self-directed way how we can explore different materials. Correct? Correct. We have a lot of materials say for about in just front of you. Correct. Now, how do we use those materials? Isn't it? So you are going to explore them. That is nothing but tinkering. Now, what is this makers? Have you heard about people talking about tinkerers and makers? So what is this makers? Any answer? Aditya, would you like to answer?
Good evening, ma'am. I am Aditya Chitnis from DPS Bangalore East. Makers are people who innovate. They are, we can say, they're a part of the future. Without them, there can be no future because they innovate what will help us in building our foundational blocks of life in the future.
Exactly. A virtual high five to you as well. Very good. So maker will make is nothing but, who creates a new product, either, for their individual use or to solve a community problem. Correct? So now, what is the difference between this tinkering and making? See, they are best friends. How are they related? So tinkering and making are related in such a way that tinkering emphasizes on the explorative aspects of making. Clear? Am I clear? Yes? Thumbs up? Okay. So now let's start. I've got quite a few experiments for you all. Let's understand how these experiments work and what do really they teach us. Okay. So first let's start with our first experiment. For this, we would require a plastic bottle. Okay. A tray or a bowl and a thumb pin. Do you all have this with you? If so, give me a high five. Yeah. Sorry, give me a thumbs up. Correct. Okay. And you also require a bottle of water. All right. First step. So I see that all of you as a scientist, for next 1 hour, I want all of you to act like a scientist or an innovator or a tinkerer. So whichever word suits, you can choose that. All right. So what do a scientist do? What do a scientist do? Invent or discover new things. Yes. He invents, he research, he experiments. All right. So what is the one common thing among these tinkerers, scientists, innovators are they find solution to a problem, correct? So now for next 1 hour, all of you are going to act like a scientist and let's explore different activities. So for our first activity, take out your bottle and a thumb pen. Okay. Step 1, you're going to make 5 holes at the bottom of the bottle. Around the bottle, make 5 holes. So you're going to make 1, 2, 3, 4, and 5. Right? Okay. Now I'm going to fill this bottle. Are you all doing along with me? Yes? Perfect. So once you are done making these holes, please be careful because something is sharp. Don't hurt yourself. Okay. So once you make 5 to 6 holes around the bottle, then use a tray. Fill this bottle with water. How much of water? You can fill it up to the neck of the bottle. So can you see? The water is actually leaking, correct? Now I'm going to close this bottle. Are you all done? So you're going to fill the bottle with water and close it with the cap. And now you need to observe what happens to the water. Is it leaking? Is it leaking? Is it leaking or no? It stops. No, isn't it? Okay, why? Now when you're doing this experiment, please be away from the gadgets, okay, from your laptop or phone. Now I'm trying to open this cap. Can you see the water? It's like a sprinkler, isn't it? So how is this possible? Did you all try it? Yes. So I could see Nitish Gar, Tanirika doing these activities. Yeah. So when you close the bottle cap, is it working? I mean, is the water leaking? No, isn't it? So what happened? How is it possible? Even though there are holes made, still the water didn't leak. Anybody would like to answer? You can unmute yourself. Yes. And talk to me. Yeah. Everybody is saying atmospheric pressure. Yes, of course. Pressure.
Aditya, you can unmute.
Yes, the water will not flow as there is no air pressure from the top. So as the atmospheric pressure will be acting on the hole. That is why the water will not flow. When the cap is open, you have the air pressure from the top, which is pushing the water down. That is the
Yeah, fantastic. Yes. So let me just share my screen. I'll show you something here. I hope you're able to see my screen, right?
Yes, ma'am, we are able to see.
Okay. Now imagine,
Ma'am, you have gone to the end slide.
is it fine, sir?
Yeah, ma'am.
Okay. So now imagine this is our water bottle. All right. So here we have filled water till the top, and outside there's lot of pressure, air pressure, isn't it? Air is creating pressure. Now, when you open the bottle cap, imagine this is me. This green t-shirt is me, and top of me there is one person sitting. So what will happen to me? Is it pressure creating on me is less or more? It will be quite less, isn't it? Now imagine there are two people sitting on me. Now how is the pressure? It's little high. Now there are three people sitting on my shoulder. Oh my God, what will happen to me? I will collapse, isn't it? So the pressure is more. So when I open the bottle cap, the pressure from outside is trying to push the water molecules down. Since there are holes, the water is trying to come out. Now, when you close the bottle cap, what happens? There is no any external force. Therefore, the water doesn't leak. So it's very simple, isn't it? I'll just stop sharing. Yeah. So did you all try this activity? Yeah. Now let's move on to our next activity. Are you all ready? So for this, I would require a glass. If you have a steel glass or a tumbler, should be fine. Okay. And a hard cardboard. Okay. Do you have them with you? Okay. And we need some water. So this experiment, we call it as anti-gravity water. So what do you mean by anti-gravity? Gravity is something the earth pulls, right? It falls down when you throw something. But I have named this activity as anti-gravity, which means it's not going to drop down. All right, let's see what's going to happen in this. So step one, I want all of you to observe. I'm going to fill this glass completely with water. Okay, that's our step one. Okay, so when you're doing this experiment, please be away from your gadgets. Step two, you're going to use this hard cardboard, cover the mouth of the glass. I mean, is my screen not visible properly?
No, ma'am, it's visible.
Okay,
Yeah.
just got a message.
Their network issue, ma'am.
Okay, okay. So children, second, you need to cover the mouth of the glass with this hard cardboard. Okay, just give a small push to the cardboard. Now what you do is turn it upside down. All right, when you turn it upside down, make sure that you hold the cardboard for a few seconds. After few seconds, just try to remove your hand. You'll be able to see the cardboard doesn't fall. The water is not flowing out, isn't it? Yes? Fantastic. Now, again, turn it back. So your time starts now. Let's see. First, fill the glass, okay, with water. Make sure the water overflows from the glass. Okay, that's the level of water you should have. So have some tray or anything underneath so that you don't pour the water on the floor. Yes. Hey, very good. The name says Sri Devi Chakravarti, but I don't know what is your name, but very good. You've done it. Good job. Nishant, yes. Pour the water till the water flows out and then cover the mouth of the glass with the cardboard. Okay. Now slowly turn it upside down. After few seconds, remove your, yes, Nishant, very good. Shreya, I think you need to have a cardboard. Is it working? Are you able to do it? Okay, good. Take out your hand and see if it works. Please be careful. Yes, Chirantana, very good. Good job. Awesome. So simultaneously, children, now you need to think, why isn't the cardboard falling off? Okay, Priya Vikram says it's because of gravity. So gravity, what does gravity do? It pulls things down, correct? But here, it is opposite. Yeah, Pranavi also did it. Very good. Good job. Vacuum, atmospheric pressure, air pressure. Okay. There are a lot of answers coming up here. I hope everybody were able to do this activity. Yes? Bhavesh, were you? All right. Very good. Very good. Okay. So children, now tell me, what is pressure? You all keep telling pressure, air pressure, atmospheric pressure, and all those things. First of all, what is pressure? Force per unit area. Okay. That's the definition. Thrust. Okay. Let's make it very simple. What is pressure? So don't tell me exam pressure. What comes to your mind when you think about pressure? Force. Okay. Is it just with force pressure occurs? Okay. I'll give you an example. I imagine that you have a balloon with you. Okay. All right. And then you have a thumb pin. The balloon is blown. All right. Now you're trying to poke the balloon with a thumb pin. What happens to the balloon? The balloon will burst. Exactly. The balloon will burst. Now you're trying to poke the balloon with your finger. What happens now? In both the cases, you are poking the balloon. One with your finger, the other one with a thumb pin. But when you poke with thumb pin, it bursts. But when you poke with your finger, it doesn't. How? Why it doesn't burst? Less pressure. Yes. Okay. So when you need to understand about pressure, you need to know two things. Okay. One is force and the other one is area. Okay. So let's see how this force and area are related to our pressure. Okay. Force and pressure are friends. They are friends. Okay. They always do the same thing. For example, if force says, I'm going to increase, then pressure will say, then let me also increase. When the force says, I'm decreasing, then what will happen to pressure? Pressure will also decrease. Exactly. Because they are friends. They do the same thing. But whereas area and pressure, they don't like each other. Okay. So when pressure, when area says, I'm going to increase, what will happen to the pressure? Decrease. Exactly. It will do only the opposite things. Okay. So here in our first case, thumb pin, how was the area? I'll just show it here. Thumb pin, how is the area? Is it small or big? Less or more? It's less, isn't it? So when the area is less, what will happen to pressure? More, isn't it? So that's where the balloon burst. Whereas when we used our finger, the area is more and therefore the pressure is less. Similarly, here in our anti-gravity water, when we turn the cardboard upside down, okay, what happened? there is air all around this, correct? So here the air is acting upward. Can you see? The air is acting upward.
Excuse me, ma'am. Can you put it near the second camera, ma'am?
Yes. Is it fine?
Yes, ma'am. Perfect.
Okay. I hope you're all able to see. So here underneath the air is acting upward and therefore that is holding the cardboard, which is not letting it to fall. Is it fine? Was that fun? Did you all try? Did you all have fun with that experiment? Yes. Very good. So are you ready for the next experiment? Yeah. For this, we would require a bowl. Do you all have a cup of corn flour? Yes, very good. And some water. Can you just touch this corn flour and feel how is the texture? How is it? Is it hard or soft? How is it? Yes. So this kind of texture, it's called as amorphous. How is sugar? When you hold sugar in your hand, how is it? It's a little hard, isn't it? So we call them as crystalline. So this is soft like talcum powder. We call it as amorphous. Okay, now take 3 spoons of corn flour to your bowl. Add 3 tablespoons of corn flour to your bowl. I hope you're able to see my activity here, correct? Yes. Did you all? Okay. The next step is to add little of water. Don't add once for all. Add little by little in such a way that you're going to mix it and it has to be a little hard. Okay. Add little of water. The consistency of the mixture should be little thick. Don't make it watery. Okay. If it is too watery, then you add some more corn flour. Okay, the consistency of the mixture should be little thick. All right. Have you all done that? You should feel it a little hard to take it out. When you're trying to remove it from the bowl, you need to feel a little you normally feel it a little difficult. Are you? Yes. Okay. It has to be a little thick. The consistency of the mixture should be thick. So once it is done, take it in your hand and now try to put pressure. So when you try to put pressure to your mixture, it becomes hard. And then when you just open your palm, you can see the mixture flowing. It immediately turns to liquid, isn't it? That is why we named this activity as magic mud. What is it? It's called magic mud, yes. All right. When you put pressure, it has to be hard. And then when you open your palm, it becomes liquid. Correct? Are you having fun? This is one of my favorite experiments here. The whole day I can sit with this and play. Yes. I see Iksha playing with it. Nice. The name is Venkatesh here. You need to use your hand. Okay, it is better to use your hand and mix it so that you feel the texture of the corn flour, the texture of the mixture, how it is exactly. Nandika Shri, very good. So Iksha, I think it has become too liquidy. You can add another spoon of corn flour to it, to your mixture, so that it becomes a little hard. Yeah, it's homemade slime, exactly. It's also called as oblique. Now, can somebody tell me why? How can it act both solid and liquid at the same time? Okay, Yaduveer says because of kinetic energy. Okay, somebody says surface tension. Yeah, you can add little color to it. Yes, you can make colorful magic mud, of course. Force, okay. Air. So, children, what is this corn flour made up of? Any idea? Cornstarch, starch, exactly. Yes, isn't it? Corn flour is made up of starch. Yeah. So these starch molecules, what happens when you put this pressure? Okay, the molecules are lined up. Okay, so they line up and they become hard. Now, when you just open your palm, you set them free. So what happens to molecules? They are all like, yes, I'm relaxed. Now let me take my form, and it goes to liquid form. Okay, since both solid and liquid it is able to take, it is also called as non-Newtonian fluid. When you punch it, it is hard, but only when you press, just place your finger into the bowl, you can see the cornstarch is pulling your finger inside. Can you? Yes? Yeah. Give me a thumbs up if you're able to do it. Yay, very good. So children, are you all liking these experiments? Yeah? Good. So while doing these experiments, this is called tinkering, isn't it? You're tinkering with these materials. You're trying to find, okay, through these materials, what is the end product that I'm going to get? All right. Tinkering is always not with only physical materials. In case if you're learning a new word, correct? It is like tinkering with your words. I see from last few days, you guys are doing a lot of things in digital platform, isn't it? You're creating apps, you're creating different things, posters and all. That is also called as tinkering. You're doing it virtually, correct? So tinkering is not restricted only to one thing. Are you all getting it, children? Did you all are you understanding it? Yes, fantastic. So now shall we move on to our next experiment? Yeah. Oh. For this, I would want you all to take 10 ice cream sticks. I hope you all have ice cream sticks with you. Yes? Yeah, very good. So we need 10 ice cream sticks and 2 rubber bands, a bottle cap. Okay, any bottle cap should be fine. These are the ice cream sticks. Okay. And if you can have 3 rubber bands, should be fine. Hope you're able to see my screen, isn't it? Very good. Yes. All right. So I think you're all still playing with magic mud. I know the whole day you can sit and play with that. It's so interesting. It's so fascinating. So now let's move on to our next experiment because we are running short of time. Yeah. So once you are ready with these materials, that is 10 ice cream sticks, 1 bottle cap, and then 3 rubber bands, just give me a thumbs up. Yay, very good. Okay. So out of these 10 ice cream sticks, I want you to separate 2 ice cream sticks. Okay, we are not using those 2 now. Now arrange these ice cream sticks, stack them one top of the other, like this. You need to stack 8 ice cream sticks, one top of the other. Done? Okay. So once this is done, take your rubber band and then make a knot on one end. At one end, like this. Okay. Ready? So you'll have to put it in the end. Don't, put the rubber band in the between. Take it to the end. Yes. Nandika Shri, you'll have to push it towards the end. You need to stack 8 ice cream sticks like this and then make a knot. Rubber band and push it to one end. Okay. Ishka, is it clear? Just give me a thumbs up if you have understood. Yes. Now, you're going to take one, that is the 11th ice cream stick, and place it between. So now we are going to separate 6 ice cream sticks on top and 2 at the bottom. Okay. And place this 11th ice cream stick between them like a sandwich. Yes. Did you understand? So once 8 ice cream stick, you stacked it up and then you put rubber band on one side. Then you separated 6 sticks on top and 2 sticks on the bottom and place one ice cream stick below. Yes. Okay. Now put another rubber band on the other end of the ice cream stick. Just follow your step 1. So it should look like this. Yeah, clear? Very good. If you didn't understand, just let me know so that I can repeat the procedure. So you need to stack 8 ice cream sticks. Okay. Put rubber band on one side, make a knot, push it to the end, then separate those 8 ice cream sticks. 6 at the top and 2 at the bottom, and then you need to place 1 ice cream stick below. Okay. And then follow the same procedure. Make a knot on the other side. Yeah, it looks like aeroplane exactly. Okay. After this, now you are left out with another ice cream stick, correct? Yes. This you will have to place it on the top. You're going to make it like like a clip. Can you see it? Like A, yes. So once you get that A form, now take another rubber band and make a knot.
Ma'am, little down, ma'am.
Yeah. Are you able to see my ice cream sticks? Yeah. You need to form a A like this. How about now? Dhruti, are you able to see it? Yes. Fantastic. Okay. What do you think? What are we doing with these ice cream sticks? I told all of you are going to act like scientists for the next 1 hour, and you didn't ask me what is that we are doing here. You need to question me, right? So just because I'm telling you these ice cream sticks, put rubber band, you're just doing it, following, without knowing what exactly we are doing. What are we doing, ma'am? Thank you, Yashashvi, for asking that question. We are making a simple catapult. Okay. So you're almost done with 90% of the catapult. Yes. Yes, Sanjay, it is catapult. Okay. Now, the next step, you have this cap, isn't it? We are going to paste this cap on top of this ice cream stick, which is the top stick. Okay. using your double tape. I hope you all have double tape, right, with you. Take a small piece of double-sided tape. Okay. And then stick it on the cap. Peel this. And then I'm going to place it on the top of the ice cream stick. So please make sure which side am I placing it. Is it towards the open end or the close end? Can you see it now, Sharanya? I've made, yeah, open end, exactly. You need to stick the cap at the open end, yes. So your catapult is ready. If you're done, can you all show it to me? Good. So I think Nitish is done, Iksha, Nandika, Shri. How does it work? Very good. That's the next question. How does it work? Okay. Once your catapult is ready, take a small piece of paper. Okay. Take a small piece of paper, make it into a ball. Okay, a small ball. Yes, thank you, Dikshita. Okay. After making it into a ball, place it, put it in your cap. Okay, that's our launcher. Okay, here we go. Now I'll show you how it works. 3, 2, 1. You need to pull the cap down and then just release it. Can you see? Did you see? The paper ball just flew away. Yeah. So that's how you're going to launch. Yes. A simple ice cream stick could teach us so much of science. Now, why should we make this catapult? What is this catapult really teaching us? It is a medieval weapon. Exactly, yes. Right. So did you all like it? Did it work? Yeah, if so, give me a thumbs up. Yay, very good. A virtual high five to all of you who did this project. Very good, very good. Okay. Now tell me what did we learn from this catapult? It's working. Very good. Yes. Any idea? Anybody would like to? Pressure is equal to force by yeah, yes. Elastic force, push and pull. Anybody wants to explain it can unmute yourself and talk to me.
Sanjay, please unmute yourself.
Lever, pulling force. Wow, you guys are thinking a lot, yeah? Very good. Spring force. Okay.
Third law of motion.
Third law of motion. How do you say it is third law?
Sanjay,
Children, you don't have to, get scared or something. Whether it is right or wrong, it is secondary. But try to attempt. Just try it out. Whatever answer comes to your mind, just tell it. Yeah.
Yes, you can unmute.
Anybody could answer. Dyutikar, yes.
Ma'am, shall I try?
Yes, please.
Ma'am, here the force which you applied on the cup, like in the downward direction, was equal like to the action force. So the equal reaction force was exerted back, causing it to flip up, and this caused the paper ball to get launched.
Very good, Aditya. Yes, that's one of the answer. So Dyutikar is unable to unmute. Could you please help him? Anybody else? Yes, Meharish Sai, you can unmute yourself and talk to me.
Yes, ma'am. Ma'am, so here,
Who's talking? Dyutikar. Yes, Dyutikar.
Ma'am, so every force, like every action has as an opposite reaction. So when you pull it down, the same force, the equal force is applied in the opposite way, which makes it launch.
Very good. Yes, that is also one
Thank
of
you,
the
ma'am.
answer which can be considered. Very good. Yes. Any other answer? Anything else? Other than whatever, Dhyutikar or the Adityas told. Apart from that, if you have any new answer, you can let me know.
Lahar,
There's
you
one
can
answer in the
unmute.
chat.
Yes, Lahar, you can speak.
Yes, Lahar.
There is some bandwidth issue.
Anybody else?
Rudransh, please unmute yourself.
Yes, sir. So I think the reason for this is elastic force that is exerted by the rubber bands.
Okay, that also could be one of the answer.
Ma'am, there is one answer which is written by Shlok in the chat. I will just read it out. He says the catapult gained potential energy, which is then transferred to the paper ball as kinetic energy.
Exactly. Very good. Yes. So that is one of the answer. So when you place the paper ball inside the cap, what happens? Does the paper ball contains any energy? Do it possess any energy? No. No. Okay. I see answers are no. Okay. Okay. So let me tell you. Whoever has said, given me the answer as no. Okay, children, any object, okay, when it is not moving, it still has an energy. That energy is called as potential energy. All right. You can take an example of water in a fish tank and waterfall. Okay. That's an simplest example that you could think about. So here, when the paper ball is placed in the cap, it still has an energy called potential energy, just that it is not moving. But when you pull, there is a force acting upon it, right? Force is nothing but push or pull. So when you pull, you are ready to launch it, right? So when you, yeah, I think now you're able to see it. So when you just release it, what happens? The potential energy is converted to kinetic energy. So any object in its moving state, it possesses kinetic energy. Clear? So catapult can teach us so many things. As you all said, Newton's third law, force, elastic force, energy, isn't it? So don't you think science is awesome? Yeah, science is fun, isn't it? All right. So let's move on to our next activity. Are you all tired? Should we stop? Or should we continue? Continue? I don't see any thumbs up. I don't see. Okay, thumbs up. All right, continue. Fine. So we have one more activity here. For this, you need 2 more ice cream sticks. Okay. And you have a paper, a regular paper, right? You make it into slit. So you might be wondering what is the size of the slit and all. It has to be exactly the same size of your ice cream stick, the width and the length. Okay, take a scissor, measure it and cut it in such a way that the length and the width of the paper slit is equal to your ice cream stick. All right. So can you all do it now? So once you are ready, just give me a thumbs up or put it in the message. Okay, Sri Devi Chakravarti. I think it's your mom's name. I don't know what is your name. Okay, ready? So you need 2 paper slips. Okay, 2 ice cream sticks, 2 paper slits, and then either toothpick or straw. In case if you have a toothpick, then break it into half. Okay. In case if you have a toothpick, break it into half. Perfect. So now you have two small pieces. Keep it carefully. In case if you are using straw, then I would request you to cut it into small piece. Like this. Okay, this is the size. So you need to have two pieces of straw. So either one should be fine. Either go with toothpick or straw, whichever is convenient to you. Are you all ready? So you need two ice cream sticks, two paper slits, okay, and two rubber bands. A small rubber band should be fine. And then in case if you have toothpick, you break it into half and have two pieces with you. Or if you have straw, you need to again have two pieces of straw, either of them. What is the activity? Yes. The activity that we are going to do now is, it's called as mouth organ. You're going to create a mini mouth organ. Are you all ready, children? Shall we start? Okay. Step 1. Place both the paper slits, okay, both the paper slits between the ice cream sticks. Like this. Okay. You're going to place both the paper slits between the ice cream sticks. Once you have placed, take a rubber band and make a knot on one side of the stick. Place both the paper slits between the ice cream sticks. All right. And take a rubber band and maybe put a knot and push it to the end of the sticks. If you're done, just let me know done or give me a thumbs up. Yes. Okay, place two ice cream sticks, sorry, paper slits between two ice cream sticks. Okay, then take a rubber band and make a knot and place it and push it to the end. Now, in case if you are using toothpick, take one half of the toothpick and place it between the paper slits. I hope you understood. You need to place it between the paper slit, which means one stick, one paper slit should go on top, the other two on the bottom. So between the paper slits, you place one half of the toothpick or straw and push it to the end. Push it to the end of one side. That is wherever you put rubber band, push it to that end. Yes, perfect. All right. Now take another half. You're going to follow the same procedure on the other side. Follow the same procedure on the other side. Again, place the other half of the toothpick on the other end. Okay. Take a rubber band and make a knot. Done? If it is done, just give me a thumbs up. So 2 ice cream sticks, you're placing 2 paper slips between the ice cream sticks. Okay. First, you put a rubber band, push it to one end, place one half of the toothpick between the paper slit, push it to the side of where you put rubber band, follow the same procedure on the other side. Ready? Now you need to carefully watch me. How this works is your question, right? Yeah. You need to place it between your lips, okay? Don't wet the paper. Don't wet it, okay? Just press between your lips, okay? Did you all hear the sound? Yes? Was it fun? Yeah, now I want all of you to blow. Yes. I think maybe a couple of you can unmute yourself and blow and show it to people. Whoever is done, Nitish, Sridevi, Iksha. So 3, 2, 1, go. 2, 1, go. Very nice. It's funny. Very nice. It's funny. Good job. Good job. Good job. Good job. So did you all like it, children? Were you all able to make this noise? Yes. This is called mini mouth organ. Okay, now you can play whichever song you want. Record it and share it with us. Okay, make a small video of the activities that you did today and share it with us. All right. So with this, I think we have come to the end of the session. So let's have a recap. Can you all tell me what was our first activity? What was our first activity? What did we do? Bottle, yes. It's called as do not open the bottle. Okay. Our first activity, the name is do not open the bottle. Why? When you open the bottle, what happens? The water is sprinkling, isn't it? So it's called do not open the bottle. Exactly. Second activity. What did we do? Anti-gravity water. Exactly. Yes. What was our third activity? Magic mud. Exactly. We did magic mud, isn't it? We used corn flour, water, mixed, and we understood why it acts both solid and liquid. And then fourth activity. I think somebody can unmute yourself and talk to me. I see a lot of messages here, but it would be better if you could unmute. And
Yaduvir, you can unmute yourself. Nitish Garg, please unmute yourself. Yes, Nitish, you can speak. Your voice is not audible. Nitish, your voice is not audible. Pranavi, please unmute yourself.
Pranavi, again you're mute. You need to unmute. Yeah, I think Nandika Shri is ready. Nandika, can you unmute yourself and tell your friends what all we did today?
Yes, Nandika, you can speak.
The first activity was don't open the bottle, and the second activity was magic mud, and the second activity was anti-gravity, and the third activity was magic mud, and the fourth activity was cat pelt, and the fifth activity was small mouth organ.
Mini mouth organ. Yes, fantastic. Thank you, Nandika Shri. High five to you. Yeah, very good. So I hope, children, you all enjoyed the session. So now, don't you think science is awesome and science is everywhere, isn't it? So do not stop your, tinkering here. From here onwards, start give, tasks and goals to yourself where every day you try out new things, explore new things. Okay. And one question which I would want to leave it with you all right now is, it's a thought-provoking question, okay? We have two cases. We have a candle, okay? And we have charcoal. So candle is lit with the flame, okay? You blow to the candle flame, what happens to the flame? You have candle with flame, right? So you blow to the candle flame, what happens? Yes, Mrinal. Mrinal, you can unmute yourself and yeah. It will put off. The flame is put off. Exactly. Very good. Now, when you blow it to a charcoal, what happens? You know what is charcoal, right? Yes. So when you blow to charcoal, what happens? It burns more. Exactly. Isn't it? But in both the cases, you are blowing. You're saying, oof. But how come only in one case the flame is put off and in the other case, the flame is ignited more? Correct? So this is something you'll have to think and you're going to answer it. That's the assignment. I think, Vijay, have you put that link in the chat?
Yes, ma'am. The quiz
the
link,
question.
right?
Yes. So children, think, don't Google. Okay. No matter if it is right or wrong, don't worry. But whatever you think, answer to those questions. Okay. I have like 5 questions framed for you. Answer it. And let's see, who gets the right answer there. All right. Yeah. Thank you so much. So science is awesome, isn't it? I want all of you to type science is awesome and clap for yourself for doing all these activities. Yes. Thank you.
Yeah, thank you, Miss Kritika, for the awesome and practical session on making and tinkering. Even myself, like many of the like 2 of the activities which you did was relatable to my 12th class syllabus. Like I was able to apply the knowledge which I got in practical sense. So that was really amazing and nice. And also, I hope the participants learned the importance of making and tinkering and also had fun with the hands-on demo and activities. Okay, so if anyone has some questions, can put it in the chat windows. We could take 1 or 2 from them, or else you would go to the end of the session if there are no questions.
Yes, Vijay, there is a
So-
lot of appreciation saying science is awesome, science is non-replaceable, science is full of magics. Yes, that is the appreciations that we got for the session. Like, hope we can conclude.
Okay, so thank you, Ms. Kritika, for taking your time from the busy schedule to conduct the webinar today. I also thank the audience for attending the webinar on making and tinkering skills. Our next webinar will start at 6 p.m. today on creative thinking and body-mind programming.
Yeah, 6
on body-mind programming at 6 p.m. today. Yes. So it's going to be a very interesting session. Even I'm interested, like, to know about what is body-mind programming. So you all can join the session through the YouTube or Zoom join link for the session through the from the website of the webinar series, Changemaker Summer Camp webinar series, and join us again at 6 p.m. today. Bye for now. Bye.